Imagine the winter has grown so harsh that the cold cuts straight to the bone. The power is out, the gas is gone, and the wind is howling outside. You look around and find only one dry branch, one single branch, standing between you and a long night of cold and hunger. If you light this branch the ordinary way, it will give you a few minutes of flame, then turn to ash and smoke, as if all the energy inside it simply vanished into the air. But our ancestors looked at this branch in a completely different way. They didn't see a small piece of wood. They saw fuel that could produce enough heat to cook and stay warm for hours if used the right way. And from this was born a remarkable piece of engineering, known today as the rocket stove, not because it produces a bigger fire, but because it makes the fire work smart. A simple stove that could be built from humble materials found in almost every village. A bit of clay, some old tin, and a basic understanding of how air moves. The result: concentrated heat, less wood consumed, and less smoke when used properly in an open, well-ventilated space. In this episode of Forgotten Survival, we continue our journey into the pillar of shelter and warmth, and we'll uncover the idea that made this stove one of the smartest folk inventions in history. If you believe that skill and knowledge are the real wealth in times of crisis, subscribe to the channel and join our community that preserves wisdom before it's lost. Now, let's start with the real secret. Today, lighting a fire is something we barely think about. We press a button and the gas ignites. We press another and the heaters start working. But fire is not just a flame. It's a precise relationship between fuel, air, and heat. And any imbalance in one of these elements means a large part of the energy is wasted for nothing. This is where the genius of the rocket stove appears. In a traditional fire, heat scatters in every direction, and a lack of oxygen leads to incomplete combustion, producing thick smoke and wasting a large amount of energy. This stove does something entirely different. It forces the fire to travel through a narrow, insulated, L-shaped passage. As the hot gases rise through the vertical section, cold air automatically begins pulling in from below. No fan needed, no pump needed. It relies purely on the laws of nature. The hotter it gets inside the chimney, the stronger the pull of air inward, and the more air drawn in, the more complete the combustion becomes. That's why users hear a sound like a roaring rush of air, and that's where the name comes from. The rocket stove. But most people assume the secret lies in the type of wood used. That's the biggest myth. The real secret lies somewhere else entirely. It's in the geometric proportions of the internal passage and in the thermal insulation that keeps heat from escaping. If either one is off, the stove loses its advantage completely. But if built correctly, even a small piece of wood can produce more heat than you'd expect. That's why this design passed down through generations like a family secret. Building it relies on a very simple idea. An outer metal shell wraps around the internal combustion channel. A gap is left between them, filled with an insulating material like clay mixed with a bit of ash or straw. This layer isn't just filler. It's the true heart of the stove. It prevents heat from leaking out and keeps the temperature inside the combustion chamber high, which greatly increases the fire's efficiency. Then a small metal piece is added inside the wood feed opening. Pieces of wood are placed on top of it, while the bottom stays open for continuous airflow. And here, nature takes over and finishes the job on its own in environments where clay isn't available. Some use dry sand or small gravel as an alternative to help retain heat inside the structure, with performance varying depending on the materials used. It's mentioned in some traditional practices that preheating the internal passage with a small amount of fast-burning material helped get the airflow moving faster, before gradually adding pieces of wood. It's told that one of the grandfathers, when the cooking fuel ran out one winter, brought an old oil tin, some clay and ash, and sat quietly building a small stove. Everyone watched him, puzzled. His daughter smiled and said, "Can this little thing even boil a cup of tea?" He smiled without answering. He lit a small piece of wood, and within minutes the water was boiling vigorously. Then he turned to her and said, "Fire doesn't need a lot of wood. It needs air that knows how to reach it." And perhaps that simple sentence sums up the whole idea. Today we depend on electricity and gas almost entirely, but any sudden outage reminds us that ancient knowledge was never a luxury. It was a means of survival. The goal of knowing these ideas isn't to return to the past, it's to understand how people solved their most complex problems with the simplest tools. The experience our ancestors left behind doesn't belong to any one era. It's knowledge that can stay useful no matter how life changes, and that's why wisdom always remains more valuable than the tool itself. If this episode added something new to your knowledge, don't forget to subscribe to the channel and like the video, so these stories can reach everyone who values self-reliance and traditional knowledge. In the next episode, we'll reveal one of the most fascinating traditional techniques, the method some tribes used to extract drinkable water from the humidity in the air in the heart of the desert. Write it in the comments now. Episode 10. See you in the next episode on the warmth of wisdom. Disclaimer: this content is intended for educational and historical documentation purposes only. Handling fire and hot materials carries real risks. Any solid fuel stove must always be used in open or well-ventilated areas, while following local safety guidelines, and never used indoors in spaces not equipped for it.